the trick is to kind of, you know, do as many sessions as we can, even if they're like 20 minutes. So I don't lose the x to that's definitely not the. What I like about this though is that it's actually squaring a. It's actually really, it's a to the cube, which is, it's actually good because that's in a way, you know, we have this here, right? And if we assume a is positive, I think we can assume a is positive because it's in a way it's got the minus already. So I think that is, because I bet if we assume a is positive, then we're gonna get a to the cube. Positive, true. Yeah. Okay, that's really good. That's actually really good because we have a to the cube now, and this is just pi, and then we need this whole thing to be square root of yeah. It's like square root of this whole thing to the cube. So yeah, so actually that might as well just be like these. Where are we? So where are we? Because when we were just staying in 2D, we were getting, what were we getting? We were getting a thing just, okay, so. A to the 3 to the, 3 divided by 2 and then square root of pi. Because this is the struggle here. The struggle is understanding the dimensionality. I'm assuming the convention is we're in 3D space, and so our function is really 4-dimensional. Because our wave function is 4-dimensional. Now, what can we do here? It just seems, so in hyperspherical coordinates, maybe there's, it just seems like hyperspherical coordinates, so quantum mechanics, this is a thing, right? Hyperspherical coordinates. So this is indeed a thing. I mean, yeah. So we use them. Hyperspherical coordinates, but okay, sure. Integral. hypersphere.
Wusstest du, dass 10.000 Unternehmen auf Shopify vertrauen? Mit Shopify kannst du blitzschnell einen...
2 is x, y, z. The new variables are going to be rho, d, theta, and another one, phi.
Okay, rewriting I don't care because it's we have that.
So people who do that probably apparently get 5 million. The 0 and 5 comes to us from the world of cylindrical coordinates, right? But in vector and other discussions, interesting one. I've got myself a sine squared t. Interestingly enough, this is still 0, and it just makes this pi over. You just, by the symmetry of the problem, you get a half of this. What if I did instead that we're looking at the same thing, but just with x and y greater than or equal to 0? What would that enforce on us? How would we impose that in spherical coordinates? So I can, just kind of...
But I thought this was they're not doing anything with hyperspheres.
Yeah.
They're just they're just doing the three yeah. It's really that one single example. No. Integration. So to use this alternate polar coordinates formula. So we use this coordinate system. R equals, so R is bigger than 0. Maybe that is the thing. Maybe R can 0. Positive true. We're almost there. We're almost there. There's just something. This has got the right shape. It's got the right form. There's something that I'm missing here. Maybe a p half somewhere. Because because if I'm imagining 3 dimensions, then actually if one is just pi halves and then we're doing pi, right? So shouldn't this be actually something like this, like it does not really change. It just changes the factor, but it doesn't change the solution very well. No, it just changes the factor. And anyway, here it says, so here is like, no, okay, makes sense, right? Pi, and then, so you're doing first the radius, then you're doing pi, and then you're doing 2 pi, right, in a way, or like the radius, then you're doing kind of like pi, and then you're doing the full thing. Yeah. And in our case, that should be fine. No, that shouldn't be fine, because you're taking more area. If you're taking the full sphere and your function is just like that cone inside, I mean, you're taking more sphere. You're taking definitely more. So it is indeed, you know, pi halves. Like if you go back to this one, if I just say, no, first we do just pi halves, and then we do 2 pi. What do we get now? We're also getting close, but not there yet. The question is in this fucking 3 dimensions, like how do we, 4 dimensions, like how do you even do this in 4 dimensions? Because how does this even translate? I just don't. Maybe I just should have everything, you know. That definitely doesn't, that's definitely not. The point. Because here we will be doing, so first integrating through R. It's a really big number. It probably helps better if it's actually infinite, maybe. Then you're just doing pi, and then pi halves, and then you're doing 2 pi. So it should be 2 pi, not pi. It should definitely be 2 pi. I feel I'm almost so close. I'm so close. I'm so super close. I'm so close. I'm almost like, oh God. So in this case, we start with R, 0 to infinite, and then pi halves and pi halves. Why isn't this then? This could be, but it's not. It's also not these. It's also not these. Motherfucker. It's definitely not these. We're so damn close. Did I put this correctly? 2 pi. Maybe in this case I also have to just half this guy. I don't think so. That makes no sense. No. Maybe this is something like this. Oh. I'm just like trial and error. No, it makes no sense. It just makes no sense. Pi half. Pi. Makes no sense. It just makes no sense. It makes so much no sense. Also, this constants there make no sense. This constants there make no sense at all. So this is phi 1 to phi n minus 1. I'm definitely actually missing. So wait a second. So phi 1, so n is 4. So we have n minus 1 as 3, and then sinus of phi 1 to the power of 2 times sinus there's no r here. What am I doing? Times sinus of, there's no r, times sinus to the power of 1 of phi 2. So this is 4 minus 3 is 1. So this is so this is 3, 2, 1, and then sinus of phi 3. 4 minus 1 is sinus phi 3. 4. I'm like, I feel like dyslexic. So this is 3, 2. So this is n minus, sorry, n minus 1. Phi 1. N minus 3. Phi 2. And then what is the what is the logic here? N minus 1. So basically, if we have 4, then we need 3 angles in here. 1, 2, and 3. But essentially, that's gonna be, yeah, that's a bit weird. Okay, I thought, because then there's definitely missing here another piece, which is so the 3 angles, but this is power of 3 and this is power of 2 and these 2 are to the power of 1. Like, that seems a bit confusing. No, okay, so because I have to go. So R, cool, and then we have these, and then we have this and this. So this was a mistake in here. Maybe that's gonna be better, maybe that's gonna be worse. Oh, it's gonna be fucking worse. Fucking worse. One, 2, and 3. 3, 2, 1. No. Shit. Oh. Unless we do these or we do both half. And the last one 4. No. Oh my god. And then we start with R and then we start with phi 1. And phi 1 is maybe the first one that is then 2 pi, maybe. Maybe that is it. Maybe that's the way. There's something like it's gotta be with these. It's just I feel so useless. Ugh, it's also not these. Fuck, I have to go. Feels so close. It feels so close, but it feels so awfully. I'm like just fucking dyslexic because I don't know where. Which is psi and which is not psi, and this makes no sense. This is a fucking mistake. This makes no sense because why if the inner one is R, it can't be 0 to 2 pi. That's a mistake. That's a mistake. That is definitely a mistake. God. How can I even trust these then? How can I even trust these? That also in a way makes no sense. Maybe I should find this somewhere else. Integral just somewhere else. Maybe there's just another way to do these. Maybe I can find. It's gonna make sense, but it's a bit. It's just abstract because of the amount of dimensions. I just don't know. Anyway, gotta jump. It almost feels I'm like there, but there's just something missing. And I don't know what.